Good evening once again. My name is Mr. Pochilola. Welcome to continuation of our lesson or topic, which is called the acids and bases. In our previous lesson, we looked at the meaning of a base and the acid, in which we said that an acid is a proton donor. All acids have one thing in common, which is to donate proton, a proton which is a hydrogen ion. In every chemical reaction they participate in, acids always release, donate hydrogen ion, which we call a proton. All right, and the base does the opposite. For every proton donated by an acid, there must be an acceptor. So bases are therefore proton acceptors, meaning they accept or receive hydrogen ions from acids that they are reacting with. Okay, so that's called the Lorentz-Bronsted theory. According to the Lorentz-Bronsted theory, an acid donates a proton or a hydrogen ion, while a base accepts or receives a hydrogen ion, which is also called a proton. All right, so going forward, we would like to look at a very useful concept related to acids and bases, and this is what we call conjugate acids and bases. All right, so pay attention, because we'll be discussing this today and look at some important examples. All right, so listen on, pay attention up to the end of the video so that you don't miss on any of the explanations that we give. So these terms, the terms conjugate acid and conjugate base, are used to describe the products of acid-base reactions. All right, so what is a conjugate acid, therefore? A conjugate acid. A conjugate acid is simply an ion that is formed when a base gains a proton. When a base gains a proton, the ion which is formed is called conjugate acid. I'll give you an example. Suppose that an acid such as HCl reacts with a base such as ammonia NH3. All right, so practically what's going to happen is that the acid, which is HCl, will donate its ion, proton, which is hydrogen, to ammonia. The product is going to be an ammonium ion, NH4+. Look at what has happened to the number of hydrogen. It has gone up by 1, and we have indicated the overall charge on the product, on the ammonia. So this, after the HCl, the hydrochloric acid, has donated its hydrogen ion or proton, what will remain of it is the Cl-, which is a chloride ion. All right. I hope we are together there. So look here, we are back to the definition of a conjugate acid. All right, so we are saying a conjugate acid is the ion that is formed when a base gains a proton. All right, so this is our acid. The acid is the HCl. The base is our ammonia. So the ammonium therefore becomes a conjugate acid. So the base becomes a conjugate acid. So what is formed after a base has gained a proton is called a conjugate acid. Take note of that. The base becomes a conjugate acid upon gaining a proton from an acid. The Cl minus is what is called a conjugate base. Conjugate base. So what remains when an acid has donated its proton is called the conjugate base. What is formed when a base gains a proton is called the conjugate acid. All right, so that's very important. I wanted to highlight this very well for you so that you don't miss this when need be in an exam. All right, for you to write down what are called conjugate acid base pairs. All right, if you have any question, don't hesitate to ask so that we can offer a more concise explanation. All right, so in this case, let's consider the following situations just as examples of conjugate acids. So if you look at the first example, example A, our base is ammonia, and the ammonia gains a proton from an acid. What is formed, I mentioned this earlier on, what is formed is a conjugate acid. So whenever a base gains or accepts a proton, the product thereof is called the conjugate acid. Another example is the OH minus, which is called the hydroxide ion. Upon gaining a proton, it's going to form water, which is behaving in this case as a conjugate acid. So the ion is called conjugate acid because if we imagine the reverse of the reaction, it can give up its proton. All right, let's imagine that the reaction is going to reverse. Let's look at the first example. In this case, we are using ammonia as an example. Let's suppose we have NH3 ammonia gaining a hydrogen ion or proton to form ammonium. So why we are calling this a conjugate base, a conjugate acid, we are imagining that if this reaction can go backwards or reverse, it means this is going to lose, or the ammonium ion will donate the hydrogen that it gained earlier on. Okay, and the result is going to be, what will remain is the ammonia molecule, okay, which is the base. Okay, so the reason why we call this a conjugate acid, we are imagining that if the reaction goes backwards, the conjugate acid will have to lose or to give up its proton, the proton that it gained from an acid. What it's going to form is the original base and the acid, the hydrogen ion that it gained before. All right, more examples. Okay, so let's look at a conjugate base. Conjugate base is the ion that is formed when an acid loses a proton. All right, let's go back to the earlier example. Suppose that HCl, which is an acid, reacts with ammonia, which is a base, to form ammonium, which is a conjugate acid, and a chloride ion. All right, so once again, this is our acid. HCl is an acid. If we are to label this, this is an acid. HCl is an acid, and this is a base. So I mentioned that when a base gains a proton, it becomes a conjugate acid. Conjugate acid, I'll just use short forms. Conjugate acid. So when the acid HCl has lost its hydrogen ion, hydrogen proton, okay, what's going to remain is the Cl minus. So this is called the conjugate base. Okay, so here we are imagining that if the reaction goes backwards, it means the Cl minus will have to gain a proton again from ammonium to form back the acid and the base that formed them. All right, so just as examples, a conjugate base, let's consider this situation here. Let's say we have acetic acid. This is ethanoic acid. Okay, so when ethanoic acid loses its proton, in this case the hydrogen ion, what will remain is this ion here without the hydrogen ion at the end. So it becomes a conjugate base. It becomes a conjugate base. A conjugate base is the ion that is formed when an acid loses a proton. Examples, we have acetic acid losing this hydrogen ion. This hydrogen ion originally was here, so it has been lost. So what it remains now is a conjugate base and a proton. All right. Another case is ammonium. Ammonium may behave like an acid, whereby it loses its proton. One of the hydrogen ions will be removed. So if we remove a hydrogen ion from it, what will remain is a conjugate base. All right, a conjugate base. So once again, a conjugate base is the ion that is formed when an acid has lost its proton. All right, some examples may assist just to explain this further. Some examples may help. All right. Identifying conjugate acid base in an acid base reaction. Let's look at these examples here. We have ethanoic acid reacting with the hydrochloric acid, a very rare case, of course. So in this case, the ethanoic acid is behaving as if it's a base, and if it's a base, it means it will have to receive a hydrogen from hydrochloric acid. So the hydrogen will have to migrate to this to add up to the number of hydrogen atoms there. That's why it becomes CH3COOH2 at the end. The 2 here indicates that there has been an incoming hydrogen from HCl. Therefore, in this case, the product is going to be a conjugate acid. The Cl minus, which remains after the hydrogen has been donated, becomes a conjugate base. All right. Another example will also help to supplement to what I've already said. The HNO3, in this case, will act as a base, reacting with an acid. All right. So originally it has one hydrogen. One hydrogen will migrate to that. What will remain is what will be formed is that the number of hydrogen ions or atoms will increase to H2, forming a conjugate acid. Remember that the conjugate acid is the product when a base gains a proton, and when an acid loses its proton, it becomes a conjugate base. So this is a conjugate base, all right? The conjugate base is what remains when an acid has lost its proton. When that proton has been gained by a base, the base changes its name to a conjugate acid. Another case, suppose we have hydrochloric acid, HCl, and a base. So in this case, in the reaction, the hydrogen ion will migrate and to be gained by a base to form H2F. So when a base gains a proton, it becomes a conjugate acid, and when an acid loses its proton, it becomes a conjugate base. All right, so these are just some examples. Okay, now in the exam, they'll ask you to write down the conjugate acid-base pair from the following reaction. All right. Okay, so what is a conjugate acid-base pair? A conjugate acid-base pair is simply species or molecules that consist of molecules, products that consist of molecules or ions which are connected by loss of one proton. So connected by loss of one proton, okay, by an acid, and by gain of one proton by a base. That's the definition. So we are saying that a conjugate acid-base pair consists of molecules or ions which are connected by the loss of one proton by an acid and by gain of one proton by a base. So every acid-base reaction contains two conjugate acid-base pairs because the hydrogen is transferred in both the forward and reverse directions. All right, let's appreciate some examples. Some examples will help. Suppose we are asked to write down the conjugate acid-base pairs for the following equations. So the first and foremost, you need to we need to label these. So in this one, in this case, this is the base. How do we know that it's a base? It shows that it has gained a proton to make NH4, and the water here is behaving like an acid. So what is formed when a base gains a proton is a conjugate acid. So this is our conjugate acid. Just to use the short forms. So this one is our conjugate acid. Okay. So in this case, the OH, after losing a hydrogen, becomes a conjugate base. So take note. We're saying this one gains ammonia gains a hydrogen, that means it's a base. Therefore, the water is behaving like an acid. So the conjugate acid-base pair in this case is going to be ammonia, written like this: ammonia stroke ammonia, ammonium stroke ammonia. So you can see here that the difference between the two is just one hydrogen proton. Notice here that we start with acid, the acid part. The acid part is here, we are assuming that if the reaction is reversible, it is going backwards. It means ammonium will have to lose one hydrogen, and what will remain of it after it has lost one hydrogen is going to be NH3, which is the base. So when writing down this, make sure that you start with an acid and then stroke base like that. So here, the NH4, if the reaction is to go backwards, will have to give up its hydrogen ion. Therefore, it is behaving like an acid. What is formed when a proton has been removed is a base. Similarly, if you look at the water and the OH, initially the water behaved like an acid. So the water here behaved like an acid. How do we know that? It gave away its hydrogen to form hydroxide. So in this case, the water is behaving like an acid, and therefore what remains of it is a base, in this case the conjugate base. Remember, we are writing conjugate acid-base pairs, meaning you start with acid, then base. All right, take note of that. Let's look at another case in which we are looking at an acid such as nitric acid. All right. Okay, let's say we have sulfuric acid reacting with nitric acid, again another rare case. In this case, the hydrochloric acid, the sulfuric acid will give away its hydrogen to this one, which looks like nitric acid. So when a hydrogen is removed, from sulfuric acid, what will be formed is this one here. Therefore, this is an acid. This must be conjugate base. And the species that gains a hydrogen is a base. Therefore, this is our conjugate acid. All right, so when writing down this, therefore, you shall write this as acid-base pair, conjugate pair. So start with acid, and the conjugate base, this one here, will come over there, stroke H2SO4 stroke HSO4 minus. Notice that these differ only on the number of hydrogen atoms. All right, so this has more hydrogen than this one here. Therefore, this is our first pair. The other pair is the species that has more hydrogen. In this case is this one, and this has less. Therefore, that's another pair. All right, so I hope we are together there. Let's move on to the next one. Here, over here, we have water. You can see water has received a hydrogen ion. Therefore, this is a base. And what is formed is a conjugate acid. And this one here is our acid. When it has lost its hydrogen to water, what remains is a conjugate base. So the conjugate acid-base pairs therefore will be, you start with acid, the acid is this one here, the one with the hydrogen less than the original species is this one. It becomes our base, conjugate base. All right. Similarly, water, this is hydronium ion, will act like an acid. Okay. So with the potential to lose a hydrogen, and what will be formed, what will remain of it is a species that has one hydrogen less, in this case water. Therefore, that's another pair. All right, so we've been discussing conjugate acids and conjugate bases, as well as conjugate acid-base pairs. Next time we meet, we'll look at another aspect of acids and bases, which is called strength. If this is the first time you have visited the channel, please don't hesitate to subscribe to the channel and also hit the notification bell so that every time we upload a new video, you become the first one to know. All right, until we meet again in the next lesson, my name is Mr. Paul Chilola. Thank you very much. Inform your friends that it's possible to learn on this channel for free without having to pay. But if you need extra lessons, special help, let's say you are learning from home, you can do that by simply requesting extra session on the number that I shared earlier on. All right, so just request the extra lessons on this channel. We are going to, on this number, we are going to arrange some lessons for you so that you can receive lessons direct to your account. For now, I wish you all the best. We meet again in the next lesson. Bye-bye for now.